AI is an incredibly powerful tool, but you already know this. You've implemented a few models yourself, but you also know it requires a lot more time and effort than simply writing code. The most common mistake we see is when people implement AI on the wrong problem. This video is going to provide you with 4 questions you should ask yourself before implementing any AI on any use case or problem. If you answer yes to all of these questions, then go ahead, get into it. But if you have a no or maybe to one of them, you should really think whether AI is appropriate for this. First off, we're going to run through those 4 questions. The first question is, can your AI affect a decision? Second question is, will the answer be worth the increased investment? Number 3, can your answer affect the decision? And yes, that's almost the same question. And number 4, and finally, the ultimate $1 million question, will you have the right data? After that, we're going to run through some common traps, problems which are good for using AI, and some problems that really don't need AI for them. Just one small note is that this advice is probably more applicable for people working in the industry with AI rather than those working on cutting edge research. All analysis should ultimately affect a decision. For example, in medicine, the saying goes, to cut or not to cut, which refers to a surgeon making the decision as to whether they should actually operate on the patient. All analysis, not just AI, should actually be asking this question of, is this analysis and is the answer from this actually going to affect a decision? AI should be used to improve the decisions in 3 areas. The first one is improve the speed of the decision. The second is to improve the efficiency of the decision. And then the third is to improve the accuracy of the decision. Improving the speed of the decision is all about micro decisions. So this would be for areas where huge amounts of decisions are meant to and have to be made, billions and billions, which are way too many for humans to make individually or way too expensive for humans to make. A great example here is reviewing transactions for fraud. Improving the efficiency of the decision is all about reducing the cost it takes to make that decision. So that could be using doctors' times better, it could be using professionals' time better in some way. The third is generally a higher stakes form of AI, which is improving the accuracy of the decision. These are for bigger things. This would be around healthcare, this would be around investment decisions, things where a lot rests on that decision. So that first question again is, can your model affect a decision? So out of those 3, improving the speed, improving the efficiency, or improving the accuracy, which one will your model affect? AI requires more investment than simple logic-based code. And sometimes the cost of implementing the AI really isn't worth the increased investment. AI will likely only be worth the investment if it satisfies one of the following 2 scenarios. The first one is, will it be performed on a highly repeated task that will benefit from further inflowing data that can be easily labeled? This is by far the most common application and is generally where we think of AI being the best suited. Once again, the fraudulent transactions on billions and billions of pieces of data is a great example of this. The second area where AI might be worth the investment is if it's going to produce some form of novel or innovative insight or breakthrough in your arena that you wouldn't have been able to get from normal computational methods. This one is much harder to do because it's requiring you to generate insights that you probably haven't thought of or are unable to think of yourself. A good example of this would be DeepMind's research through AlphaFold, where they use it to visualize structures of proteins that humans have been unable to visualize. I know it sounds like we just asked this in question 1, but trust me, it's important enough to ask it again and also ask it in a different way. Not only does your model need to be working towards affecting a decision, your answer needs to actually affect that decision. Your answer needs to be presented and explained in a way that a human will interpret and actually act upon. Telling someone that a person has a 73% chance of cancer or that transaction has a 22.3% chance of being fraudulent generally means nothing to anybody. What they need is an actual answer or enough context around the metric, the number, the traffic light that you present that they can come up with an answer for themselves. The answer also needs to be explainable. Otherwise, a human will quickly distrust the AI and will not use it. Okay, so you're at the point where you know you're affecting a decision. Your answer will be able to affect the outcome. And importantly, it will be worth the investment. So now you need to determine whether you're actually going to have the tools available to be able to do this analysis. And this is data. And there are generally 3 things you want to ask yourself before starting an AI problem about your data. The first is, and it's pretty obvious, are you going to have sufficient amount of data both to train and validate? Now, this isn't just about having enough lines in your CSV. This is about having enough structured data and enough labeled data. The second thing you need to consider is your ground truth realistic, unbiased, and importantly available to you? This includes both on the true positive and the true negative side of things. Just having the positives or just having the negatives generally won't be sufficient to train your model on. And now the third question you want to ask yourself is, what biases are you introducing into your model with this data? This wasn't asking whether you will be introducing biases, it's asking which biases you will be introducing. All data will contain some form of bias because it is not exhaustive, and you need to be on top of that. What are the most common traps or pitfalls that we see people fall into? The first one is simply that the AI is nice to have. Someone in management thought it would be a great idea to be able to put AI and machine learning on the brochure. So they said, let's do a project on that. In reality, what was already in practice was doing pretty good, and AI maybe might have helped. Second one is that the cost of labeling new incoming data is not worth it, so the AI stagnates. This is a big trap in medical as well, because the cost of a doctor's time is very, very expensive. The next trap that we see the most of is the AI seems right. What this generally translates to is, I'm not convinced, or it's not explained enough. Sometimes as well, the AI might just simply identify a gray area case as a gray area case. There is a 53% chance that this transaction is fraudulent. Does that mean you should stop it or you shouldn't stop it? And then a final common trap that we see is that data is available, but it's incredibly unstructured or it's unlabeled and unworkable. The first one is scanning images for cancer. This is good because accuracy is highly important. Scans are growing faster than clinicians, meaning human power is going to be the bottleneck at some point. A clear-cut answer can be provided in, yes, this patient should proceed for further investigation, or no, this patient shouldn't. And then finally, data is available. Now, nothing is perfect, and the issue that we've found with our startup is that getting the data labeled on the other side of it is very expensive, as we've already mentioned. Another couple of good examples are extracting and digitizing text from hard copy documents. Another one that we've already mentioned is visualizing structures that humans can't see, such as the AlphaFold work. The first one that I'm going to mention here might be a little bit controversial. Forecasting commodity prices. This ticks all the boxes except for the ground truth in data. Commodities are a complex, chaotic system with a long-tail distribution of possible outcomes. An incorrect answer on the wrong day can completely knock you out of the game. Another bad example is most purchasing option systems. I say most. And the reason why is that the endpoints on this data is usually not available. And when it is available, half the time people don't really know why they made decisions. Generally, a great predictor of what someone is going to purchase is what they've already looked at or what is sitting in their basket already. The exception here is probably Amazon, who would have an immense amount of data on all of this and have probably figured out something smart with this. AI is powerful, but it's not suited for every single problem. To make sure you're spending the right time on the right problems, ask yourself these 4 questions before diving in with AI. Can your model affect the decision? Will it be worth the increased investment? Can your answer affect a decision? And finally, are you going to have the right and sufficient data to solve this problem? Thanks again for listening. Subscribe, like, do all those things. Any feedback or any suggestions, please let us know in the comments, and we'll see you next time.